Hello? Can you hear me? Okay. So let's start. How we can move? So I think we have already passed the start, the kickoff point that we are developing agentic applications, Gen AI applications. We are going use cases and we are exploring, we are experimenting, and we are becoming a bit skeptic how we can move things from piloting to production. And when we move fragmented pilot things to production, things are not usually going as planned as we wanted. So what we're going to cover today is identify the gaps that this is happening, what is agentic AI in general and the core capabilities, what is the reference architecture of an agentic platform, not a POC, but a platform be able to host several AI use cases, what are the integration patterns that we are using, connecting the platform to enterprise data, what is the power of few components of the architecture, which is the agentic discovery and marketplace, how we can increase the adoption of the solution by personalizing the user experience, how we can introduce observability, memory, agentic operations in the process so that we can have governance and sustainable runtime environment, how we can manage responsible AI, and how we can have some blueprints about governance in order to proceed further and be able to operate in a more sustainable way. So, starting about the enterprise gap. So this is about research. Most of the use cases, most of the companies and their enterprises, 50 to 80% of the pilots are not proceeding to production for several purposes. 1/3 of the enterprises are not having scalable solutions when we're talking about production environments. They have pilots, they have solutions that are struggling when we're talking about scale out to different kinds of markets, to different kinds of audience, to different kinds of capabilities. And most of the enterprises are spending three more time from the effort perspective on dealing governance compared to finding the right model, fine-tuning a model. So we came to a conclusion that, okay, now it is easy to find a model that is going to meet our expectation, and now the difficulty is how we can make governance in place so that we can secure what the model and the whole architecture is promising to us. But the reason for all those kinds of things is, apart from the data, which is fundamental need for agentic AI in general in use cases, is we are working mainly with fragmented pilots, so we are not scaling something from the beginning with the right architecture. We are not using reusable components, so we don't use marketplace of agents, registry. We can use reusable components to be executed on several kinds of use cases. We don't emphasize a lot on observability. We don't understand what is happening underneath, so we are designing and then we execute. And most important, we are taking in the consideration the governance and the control late on the process. So when we build the product, then we start injecting governance and how we can control operations in the solution. So those are the main topics why we have a gap and we're not easily move from pilot to production agentic use cases. So more specifically, what is an agentic AI? Agentic AI is a system having a target to solve. It's not about chatbots, it's not about a generative AI application, it's about a system that can be as autonomous as we want, trying to solve a specific goal. There are several kinds of use cases. Imagine a flight booking or a planned trip application. So there are several use cases that we can imagine as an automated agentic solution. We said it's the goal-driven, so it is trying to solve a specific goal, not a specific task. They have a process to decompose the goal, to decompose a complex task to small tasks so that it can be easily managed by reusable agents, or trying to narrow down the complexity of the whole solution. They use tools and APIs grounding enterprise data, so we're not talking about what the model or the system has been trained off. We're talking about how the system can utilize runtime enterprise data to complete a specific task, and it has the ability to reflect and adapt, learn, and become better. A reference architecture, a high-level component of a reference architecture of the solution consists of those kind of 5 layers. There are more, but those are the most important ones. So, agentic marketplace. When we build agentic solution, it is very important from the beginning trying to use a registry. So we register agents and we introduce them to be reusable. So when I build an agent for a specific task, I want this agent to be able to be selected by any other agentic use case when it is a decision to go for. So this is very, very important. An orchestration layer is another important one. So when we have a problem to solve and when we decompose a problem, it is very important to have a process, to decompose, to have this kind of decomposition as a process, to break down the things that needs to happen and try to find a way to orchestrate a sequence or a workflow in order for this problem to be solved. Integration layer we talk about, which is how we can ground enterprise data, but only not technically how, but how we can do it in the sense that, okay, we have some patterns to introduce, human in the loop, always cross-check, validate. So there are several patterns that can be used if we're talking about integrating corporate data to, let's say, to the agentic solution. Shared memory, we're talking about systems that learn, so they need to have memory, that have short-term memory, they have long-term memory. There are memory to depict several kinds of behaviors, but also there are knowledge that needs to represent it through a process of reflection and adoption. So those kind of things needs to be stored somewhere so that the agent can learn and can perform better. And final is the governance layer. Is the layer that is important to secure that the model is not hallucinating, the system is not hallucinating, the system can reply as it should be, or the system is learning, or we avoid issues that we don't want to avoid when we talk about a production system and not about just a POC or a pilot. An agentic component, a component view of the agentic solution consists mainly of those kind of 5 layers. It's a perception and input handling. So every system needs to have a component to be able to understand what is happening in the environment and how the agentic system acts with an environment, how the environment is changing, and those kind of changes need to be back in order to back propagate the whole knowledge to the system. There needs to have a planning process and a task decompositional process. So we need to understand what is the target, we need to decompose those kind of items in small tasks, and we need to create a plan how those tasks are going to be resolved and which sequence is going to be used, or what agents needs to be involved in order to take those kind of tasks and starting resolving the individual task. This is a phase that we call it usually planning and task decomposition phase of an agentic solution. There is a reasoning and decision making. So it's very important when you need to create a plan or to make an action to have a reasoning process to take decisions, because some decisions, either selecting a right agent or trying to decompose when we have a conflict about, okay, this goal, how it is going to be decomposed. Maybe there are several plans to be used. Which is the plan that I need to focus and I need to follow? So those kind of reasoning process needs to be there in order to help the agent quickly and usually run time to be able to select a plan in order to proceed to the solution. There is an action and tool calling component. So when we're talking about an agent, we want both to have information to our enterprise and corporate data, so we want to have the grounding as a capability for agent, but also we need the agent to be able to act and alter the whole, let's say, system or the environment that the agent is operating in. So this kind of layer is also offering the capabilities and the tools so that the agent can interact with the environment. Memory, we talk about it. It is several categories, and there is a slide that you can see how we can manage memory in general in terms of components. Communication is very important, how the agent can have an efficient communication between them. And finally, the learning and adoption. So how the agents are performing and how the agents are adopting through the process. This is a complex slide, but just for you to understand and use it as a reference, as a runtime architectural component. So theoretically, we talked before, what are the components that it's a must for an agentic solution. But if we're talking about how we can put it in a sequence and how we can have a runtime view, this is how it needs to be represented. So there is an agent in the center, interacts on top with a user or with a system or with another agent that is interacting by prompting and getting responses. There are controls in place for governance and responsible AI in place so that we control what the input is and what the output of the agent is. We have different kinds of layers. So we have orchestration layer, we have input layer. We're coming from the left, going to the right, information coming through the integration layer. They're passing through the pattern layer, so identify when the human needs to be involved in order to check that something is happening, when there is a need for another agent to control what information is flowing to the system. So those kind of patterns are in place. And on the middle, as a circular process, it is the core of any agentic system, which is the perception, which is understanding the environment, orchestration engine, trying to use the patterns and the flows that needs to be in order for the agents to be orchestrated, the model itself, and we're talking about agentic solutions, we're not talking about LLMs only. Imagine that any model is a part of the agentic solution, depends on the problem that we're trying to tackle. And the task decomposition phase, which is the phase that we are decomposing the initial go to several tasks, and there is a process trying to identify, do I have in my registry the agents to solve individual tasks? Yes, I have it, so I can use them. I don't have it, but I have in my registry agents that are offered as a solution from another vendor for another platform. So I can use those agents to take a task, resolve it for me, and the output is coming to the system so the next agent can take over. So it's an orchestration of agents trying to solve individual tasks, contributing to a final goal that the agent is responsible for. So now let's go to the most important components of the whole architecture, which is starting by the integration pattern. So when we talk about integration, we talk about feeding the agentic system with the right information. So there are 4 major patterns. So one is just using the LLM. So you can use prompts, actually. So we're passing the information through a prompt, and you have a way to manage the prompt. It's the most simple and quick solution to proceed further. But it's not effective when we're talking about many documentation, structure, unstructured data, a lot of information to be, let's say, used by a system. So this is why RAG is coming to the picture. So when we want to minimize hallucination, try to manage complex documentation and knowledge, RAG solutions are there in order to be able to help you ground the information for the agent. If RAG is not the most appropriate for the use case, or you come to the point that, okay, you cannot improve the efficiency of the responses by RAG, so you're using fine-tuning or small language models that are managed and trained for the specific data sets that we are having as a target to feed to the system. And finally, it is the agentic RAG, which is a capability, a pattern that it uses the RAG for the unstructured data, but also other techniques like SQL, natural language to SQL, semantic, graphs, or whatever, trying to manage the knowledge that is structured and stored in different kinds of databases or different kinds of tabular form. So based on the use case, selecting the right pattern is very important for trying to feed the system to the information that you want to. The task decomposition and the agent orchestration, we talked a bit before. So how it works. Usually there are 2 main categories, the dynamic and the static process and orchestration. So when you don't know and the agent dynamically decides what is the path that needs to follow in order to solve a complex problem. And in the static, when you know in advance that you have a specific workflow that the agent needs to follow, the agentic system needs to follow, in order several agents to be involved to solve tasks that are decomposed. So the technique is usually the chain of thoughts. This is how we start breaking the complex tasks to different kinds of individual tasks. And there are state machines that are used, fine state machines, to be used to illustrate or at least to to help on the process orchestration. So when you have a static process to follow, usually having a finite state machine can be easily identified as a graph by the agent. The agent can follow the specific, let's say, direction in order to solve the problem. And you can imagine, for example, having a goal and several agents need to be involved. And then a real-world example is a trip booking application or a solution that you need to have the flight, first of all. You need to check for trains, hotels, the payment, and finally making the final booking. So all those kind of process, imagine that as we are doing software development, we break down to subroutines, to different kinds of applications, the same pattern is used for the agentic solution. So we try to solve a problem by decomposing as autonomous as possible tasks to agents, and the agents are going to solve it for us. So the agent discovery and marketplace. So because we are not building an isolated proof of concept or a use case, we're building a platform. And the idea for building a platform is to be reusable, to be able to save time for the next use case to come. So we're trying to make the right architectural choices as fast as possible, try to build a solid foundation for the system. So one of the important components is the agent discovery and marketplace. We develop an agent. The agent can perform very well for the specific task. So we need to register the agent in a marketplace to be reused, to be able to solve other tasks that are eligible for or has the knowledge to do so for other use cases and other agentic systems. So the way that we are doing this kind of process of finding the agent, there are several techniques. So there is a capability matching. So each agent have a card that refers the capability, the descriptions, the skills that the agent have. So based on the problem and the task, there is a process that an LLM or a different kind of model checking for finding the right agent for the problem. There are different kind of cases for model for ranking to run. So there are several cases, tasks that can be solved by different kind of agents. We need to rank those kind of agents, which is the most appropriate. And there are several techniques and patterns, and this usually happens in real-time use cases. You have the decision to assign the same task to 2 or 3 different agents that scores better for taking a specific task, and you can evaluate the response, and you can take the action to use the output of each of the one of them, or at least one of them. So there is meta learning process. So you don't count only on the description of the skills of the agent. You are using those kind of findings on the metadata that you are creating and the process that you have already used in order to be used and learn and improve the process of finding the right agent for the solution. And there are also several kind of workflows that can be used for static use cases. So when you know in advance that in order to make a trip, you need to do specific tasks in a row. So this is an easy case to simulate how a series of agents can be involved trying to solving a problem. Everything that we discussed so far has to do with the performance of the solution, how we can increase the performance solution. But it's not the only one that we need to consider, because we can create a product, we can create an agentic solution, but the adoption of the agentic solution is, again, one thing that we need to consider. And there are several ways to manage how we can increase the adoption of the solution by personalizing the user experience that we have with an agentic AI solution. There are 3 main pillars that we need to consider. So personalized interaction, so how we can adapt the language, the way that the agent is interacting based on the persona that is using the system. We have a use case context pattern that will say, okay, I have a specific use case, so an agent can be used by different kinds of use cases, and the agent needs to act in a different way because the context of the use case is totally different from between the 2 different cases. So the agent needs to be able to adapt his way that he's communicating, interacting with the personas based on the use case, not only based on the person that he's talking to. And finally is that we need to find a way, and we need to consider how the agent can proactively interact and not only accepting prompts, but trying to create the engagement that we want by throwing messages, by triggering events, by sending notifications to the user when there is a valid information to be shared with the user. So there are several kinds of cases that we need to consider when we talk about adoption and how what have been designed can be used and adopted by the people that are going to use it. The memory. The memory more or less mimics the human memory of an agent. So we have several patterns for memory. So we have semantic memory. So we have the knowledge. We store the knowledge in facts, concepts, meaning. So we're trying to understand how we can represent the information and the knowledge that we have in a way that the agent understands the context of it and not just keywords trying to predict letters or whatever. So we need to create the context, the semantics, so the agent can understand about the memory. They have episodic memory, so when there is an incident, when there is an action, we keep record what is happening so the agent can use this kind of event, episode in order to adjust that, okay, he needs to follow the same pattern, he needs to follow the same process. So it is easy to help the agent not try to deviate from one process to another by giving the opportunity to have this kind of episodic memory. So he knows that he used very well a specific pattern or a flow. Okay, when I have a similar case, I need to reuse the same. We have the procedural memory, so skills and processes are stored as a state machines, as a workflows, as a whatever, let's say, structural graphs can be used for process memory. And we have also the emotional memory, so sentiment analysis used for creating patterns, for driving different kind of experience for the user. So if I'm talking about a specific use case, contextual awareness of the use case is stored in this episode, it's emotional memory. So when I'm talking about the same use case, I can react the same. When I'm talking about a different use case, I can react again based on the use case that I'm reacting or based on the persona that I'm discussing with. So the memory is storing prompts, storing it's a memory router usually, so the agent needs to identify how he can take advantage of those different kind of layers, when I should use semantic memory, when I use short-term memory, when I use long-term memory. So usually those systems have a memory router, so someone to help the agent to go through the patterns or the memory places that needs to go there. There is a short-term and long-term memory. The short-term, usually it is vector databases, when the long-term, you will prefer graphs and knowledge graph for storing, let's say, episodical events, patterns, and those kind of things. And we have a process to transform STMs, or the events for the short memory to the long term when we're talking about something that it is reused. So we control the analytics based on the observability. When a specific part of the memory is frequently used and it is accepted by a lot of agents, we have a process to offload the short memory and we move it to the long memory so that can stay as a permanent knowledge for the agentic. Observability operations. So it's a core when we're talking about agentic, because we're talking about improving the system. We're not talking about just creating a system. We're talking about how we create something that we need to control, we need to measure in order to make it better the next time. So there are several challenges, and imagine, for example, decomposing a system like microservice architecture. So it's even difficult because currently we're not talking about, we don't have a global observer. So there are things that are happening in parallel. The agents are acting in parallel, and there are decisions that making very frequently happen dynamically without having a predefined state machine of going through those kind of decisions. So when the agents execute tasks in parallel with decisions that are taken very ad hoc, this creates and increases the complexity, how we can observe and how we can represent what we have observed in order for us to understand what is happening, and finally for the agent to use this information in order to feed it as a process in order to become better. So usually what is happening, we try to organize our logs in several kind of ways so that we can benefit of the observability capability. So we have local queries, so when the agent is solving a problem from himself or a task from himself, we keep this kind of in a local state for the logs. When we're talking about composite queries, so a task that needs to more than one agent to be responsible for solving a process, or we aggregate agent and knowledge to solve it, this is a complex query, and we keep a different kind of pattern for storing the logs and the information that we want to collect. Historical queries, so when we have hierarchies between agents predefined, so an agent that has several other agents working for him, and there is a strict communication between the design. So those are hierarchical queries, and we need to find a specific way to represent them. And finally, relationship, when there is an orchestration and a planning that is happening, that it is across agents, across levels, so we are keeping this information in a different way so that we can understand what is happening. So the combination of all those kind of stateful query types for storing this information is very important for us to understand what is happening and either have the opportunity to react real time on the runtime or offline on regular basis. We can understand and adapt the knowledge of the agent. Now, when we're talking about responsible AI and governance, usually we're talking about three pillars. Reliability. We talk about how we can control the consistency of the prompts and the responses to prompts. We deal with bias and fairness. We know we need, when we have multiple agents solving a problem, the problem becomes bigger. So it's not having to control one agent and trying to see if the agent is biased or it's treated with fairness. So this is how we improve the complexity, but we manage usually with curated prompts. So we need to understand and build the prompts in a way so that we can manage both to control bias and fairness. And final, hallucinations, we talked about before. So we have, from the design point of view, when introducing RAG or agentic RAG, we eliminate hallucinations, but we have evaluation techniques to be able to identify hallucinations, try to either stop or inform the user that, okay, the agent is hallucinating, to cross-check and validate. And there are several techniques to do it with citation, with explaining what's happening. So all those kinds of techniques are evaluation techniques that are helping on the reliability of the system. Now, when we are talking about reproducibility, so evaluation during training. So when we train a system and when we design a system, we're using data either from RAG, because also we can consider RAG, okay, it's not a training the LLM, but also building a knowledge, so retrieving the right information to augment a prompt as RAG is operating is very important. So we need to have a process to retrieve the information that we want based on the prompt and the task that we are assigning. So models also can be used to be able to find the right information so that we can augment the prompt. So this kind of evaluation is very critical during the training of the model. Inference evaluation. So we need to manage latency. We need to find the right model for the right use case. We need to find how we can find techniques, either streaming data and having a continuous process for feeding the system instead of waiting the system to be prompted and then to get a response. So there are several techniques to improve the latency, both from the first token reaction, but also in the total, let's say, reaction for the response. And having human in the loop is very important, both for deciding and validating plan, but also accepting the final outcome. So even the human can interact during the process. So is we asking for someone to validate a plan or to validate a process before the process continues in another state, or we left the agent as autonomous as possible to complete the task and we ask for acceptance before the action is completed. Explainability is very important because the systems that are conversational and very interactive, we need to increase the trustworthiness of the system by giving an explanation to the user, to the operator, that the agent is doing something that's supposed to do, and we can validate the process of doing it, so we trust more the outcome because we understand the process. Right? So this is very important to increase the adoption also of the solution, because trustworthiness is very, very, very important. So building the governance in the platform. Privacy security is important. Human in the loop is, again, important. Audit and transparency, traceability is something that we need also to keep logs, to understand, to go back and see what happened in a specific case. So it is very, very important. Bias mitigation, we need to introduce and manage, we need to introduce processes to manage bias, and especially on the RAG applications or a fine-tuning use cases that we want to go and train a specific model. Regulatory compliance, so we need to be careful about GDPR, EU Act, so especially when you're building critical applications that are autonomy, interacting with customers, you need to think twice how we are moving things to production and what we are putting as a control in order to be able to catch up things that we are never experienced in the process before. And continuous evaluation, we need to put the guide rails both offline to train while we are developing and testing a system, but also how we can evaluate real-time the responses and the plan that a system is generating so that we can increase the trustworthiness of the solution. On the evaluation, which is happening, is response and accuracy and relevance. So there are 4 pillars. The first pillar is about how we can secure the responses, that we are controlling the hallucination rate. When we're talking about LLMs and agentic solutions and autonomous solutions, we're talking about a probabilistic process. So the error, it's a part of the solution. The hallucination is something that we need to manage anyhow. So hallucination-free usually is not easy to come. So we need to be able to manage and count the rate that the system is hallucinating in order to be able to control it and manage it. The less is the better, but we need to handle the process. Checking the correctness and the groundness of the responses and the actions that the system is doing. Contextual relevance, so we need to understand that, okay, the context that we are both feeding, but also the agent is generating, is relevant to the case. And we need to have RAG metrics. There are specific metrics that we can measure the RAG performance, no matter if it is agentic or not agentic RAG, or if it is structured or unstructured data. From the responsible AI and regulation, explainability, scoring, toxicity and fairness, privacy, compliance, EU Act, mapping. So there are several categories that we need to consider, and how we can categorize the application based on risk, and how we can identify risk and what needs to be done in order to mitigate if a risk is happening. So those kinds of things needs to be there as an evaluation process. From the user experience, we said about latency, about personalization, about if there is an error, how we can recover from the error. User engagement, we need to measure adoption, and we need to understand, okay, maybe we have a perfect system designing for the goal, but the user, it's not easy for them to use it, so we need to measure this kind of engagement rates for the system to be adopted. Cost or energy efficient is very important. So how many APIs we're talking about, how many tokens we are consuming, if this is efficient, the model that we have selected, both from the performance but also from the token consumption. We need to have different kinds of strategies for different kinds of problems, but in order to be able to manage them, we need to measure them and we need to evaluate it. So the enterprise implementation journey, in the journey of the use case, usually there are 4 stages. So usually we identify the right scope. It's very important to find the use case that we want and to have the scope clearly identified before we proceeding with a pilot. When we're proceeding with, when we want even to transform a pilot to go to production, we need to rethink about the scope and try to validate that the initial scope is the same, or the scope has been altered, so the solution needs to be adjusted accordingly. We need to architect and design in advance. So we're not building something that is one-off or a fragmented POC. We don't trying to be fast. We need trying to build something that is going to be solid. It needs to be extended as a platform, be able to help you to the next use case that you're going to deal with, to the next POC that you're going to deal with, or to the next problem that we're trying to resolve. So design it in a way to have components, to have layers, to have reusable as a principle for you, so that you build something that can evolve as a platform, even not as a complete platform, so you don't need all the layers and all the components for all the use cases. Start with the components that you need, but while we are developing, you need to design it in a way so those components are components of a platform and not the components of just a solution. Build and govern. Build from the beginning, but also insert governance or deal with governance from the beginning. Don't think that, okay, you're going to develop a system, be able to reply and respond, and governance is something that comes at the end. Governance needs to be there from the beginning. Governance needs to be there from the design. It's part of the design. Try to have LLMs as a judge, different kinds of techniques, processes, human in the loop. Design it from the beginning, having governance embedded as soon as possible from that perspective to save you time, because then you're going to realize that you cannot go to production and you're going to fail because you have to redo it again because you designed something that is fast but cannot go to production. And finally is the scale and operate. Build it in a way to have operations, monitoring, to have ops in place, to have continuous evaluation, to have those kinds of techniques so that you can manage how we can scale, how you can take more traffic, more problems, and more users to use the final system. So, as a checklist, I'm not going to go in the detail because I need to give you some time for questions if you have, but in general, you can use it as a checklist. So, from the governance perspective, from the operation, integration, and scalability. So, there are things that you need to consider. A check that you have considered those kinds of things in every stage from the starting of the solution until the delivery of the solution. Finally, the key takeaways. So, design as much as modular as possible. So when you design something, it's a principle from software engineering in general. Don't design an agent, design a platform, design an agentic solution or a platform that is going to host many use cases in the future. So don't treat the use cases that you're working with as a fragmented pilots. Think that all those kinds of things can be orchestrated, can be presented in a platform that has a marketplace of agents and orchestration, integration, and memory and governance, at least as layers in your design. You can have more based on the complexity of the use case, but try to build in a way that you can modular, you can host something, implement something that can host several kinds of use cases. Personalization. It's important to manage the personalization and the user experience. So don't design something for you, design for the personas that is going to use it. So try from the beginning, identify techniques. Either you're going to have an agentic UI, so the UI is going to be totally transformed based on the experience, on the context of the use case or the user, or you want to be a little bit more static, but again, think about the user experience. Observability is very important. Think that if you don't measure it, you don't know the problem, you don't know the success. It is important not treat a system, an agentic solution, as a simple solution for observability. There are problems that we mentioned before, like parallel processing, dynamic thinking, decision-making. So there are patterns that you need to deal with. So observability is a must for you to learn what is happening, but also to help the agent avoid the same mistakes the next time. So I think this is, and governance is the last, which is a must. So I think this is what I want to present it to you. I hope you like it, and I'm here with you for questions.